All right, number 12. If a ball is thrown into the air with an initial velocity of 40 feet per second, its height in feet after t seconds is given by y equals 40t minus 16t squared. Find the average velocity of the ball for the time interval beginning at t equals 2 seconds and lasting 0.5 seconds, 0.1 seconds, 0.05 seconds, and 0.01 seconds. So I'm going to model the first part. So that is 12AI. That is at 0.5 seconds. So what we're going to do is we're going to be determining the average velocity from 2 seconds to 2.5 seconds, because our time interval here is 0.5 seconds. So we are 0.5 seconds ahead of where we began. That is, in terms of our situation here, our point P will be at 2, comma, f of 2, and our point Q will be at 2.5, comma, f of 2.5. Now do note in this situation, our f of x is going to be our function here. So remember, y is equal to f of x. So in order to find f of 2 and f of 2.5, we will simply substitute our values into the function. So for example, we have here f of 2, that will be 40 times 2 minus 16 times 2 squared. Let me try that again. The order of operations came out wrong. So 40 times 2 minus 16 times 4, because 2 squared is 4. So we know that f of 2 is in fact 16. So our point P is at 2, 16. And we get that simply by replacing t with 2. Now similarly, we can calculate for 2.5. 40 times 2.5 minus 16 times 2.5 squared, which is just 2.5 times 2.5, and that is 0. So our point Q is at 2.5 and 0. Now, what we're trying to do here is find our average velocity, or the slope of the secant line, between these 2 points. So our average velocity here is going to equal the difference in our y's, so 0 minus 16, over the difference in our x's. So 2.5 minus 2. Okay, so that is on the numerator negative 16, and then in the denominator 0.5. So we have negative 16 divided by 0.5, which gives us that negative 32. So we can see here at that time interval, the average velocity is 32 feet per second. And we essentially repeat the same process for 0.1 seconds, so that'll be 2 to 2.1, and then for 0.05 seconds, that is 2 to 2.05, and so on.